last night, and I hope this went very well, that this was a comfortable experience. There's one part for sure I want us to talk about. Alright, so in part A, the acceleration at time 3 is the derivative of the velocity at time 3, so you get negative 5.4668. Or negative 5.466, negative 5.467. 3 places after the decimal. I always go with more, but like negative 5.466 or negative 5.467. 1 point for the number, centimeters per second squared or centimeters per second is the units that gets you the second point. Is everybody 100% okay? Yeah. Good. All right, the speed of the particle increasing or decreasing. First, find the velocity. It's some negative number. Then find the acceleration. It's some negative number. Show me that you found both. Get a point. Your conclusion, since the velocity and acceleration have the same sign, the speed is increasing at t equals 2, second point. You doing well? Alright, part C, all I needed to see was that you set up your definite integral from 0 to 3 of the absolute value of v of t dt. You get 1.702. 1.702 doesn't count as the right answer though.
1.7.
Because it says to the nearest tenth. Right, so the general rule is 3 places after the decimal, but sometimes the College Board says other things and you have to go with that. Alright, total distance traveled during the 3rd minute. We talked about this yesterday. You're going to integrate from 2 to 3. Absolute value of the speed function, 0.7175. Curious, how many of you guys get like all 8 points? Okay, 7 out of 8. What's the point that we're losing for the 7 out of 8 people?
I didn't write the v of 2 and a of 2. Like,
oh, you just like had the statement?
Yeah.
Right, and so like you need, that's your justification is that you show me that you found the velocity and the acceleration. Other places where we lost a point.
The calculation for the
Okay, so for some reason your calculation came out wrong there, but good everywhere else? Okay, that's weird. Any others? Everybody good? Alright, so let's go for the push now. Alright. Yeah, who knows? Alright, determine the position of the particle the first time it comes to rest. So the first time particle comes to rest is whatever this root was. So 1.7725, and then I did my favorite thing, I stored it. I just said, okay, that's A. From now on, 1.7725. The position then is going to be 5 plus the integral from 0 to a v of t dt, and you're going to get 5.894 for a total of 3 points. 1 point for finding the root, 1 point for your setup, which is the fundamental theorem of calculus, and then 1 point for a final numerical answer. I'm really curious, how many of you guys got all 3 points on this one? Okay. Okay, I'm curious, why is this one a fundamental theorem of calculus question? What in the problem tells you it has to be a fundamental theorem of calculus question? Andrew, what did you see that told you FTC?
Oh, because in the beginning of the problem it says that the position of the particle at time t is x of t, and the position at time t equals 0 is x equals 0.
Right, so they told you you have a position at some time, right? And so I want the position at some other time. Well, it's going to be the initial position plus the integral from 0 to a of the derivative of the position. But what's the derivative of position? Velocity. Right, the thing to keep in mind is that this guy here is displacement. The only thing that your integral can tell you is how did my position change. Right, this guy here is your initial position, and Lewis, I see you. But you're going to have to put all of these together to get the final position. You can't determine final position just by doing an integral. You have to consider initial position plus your change to get to final. Lewis.
I got all the answers, but I didn't write x.
Okay, so did you do like 5 plus blah blah? That's fine. Alright, so very likely if you didn't get all the points in E, you're not going to get all the points in F, because it's the same thing. right? Position at time 2 is position at time 0 plus the integral from 0 to 2. And then you do your setup, midpoint method, 4 rectangles. Each rectangle has a width of 0.5. You're going to go from 0 to 2, and so if you're using midpoint method, it's 0.25, 0.75, 1.25, 1.75. Grand total 5.8374. All right, part G. This is where, and actually there was a question kind of like this on the quiz that I want to talk about towards the end of class. The very last part on the quiz asked for an integral expression that tells you like how much sand was in the bin at a particular time. And a lot of you all turned that into, I have to do like an infinite Riemann sum. If I need you to do an infinite Riemann sum, I'm going to use the words infinite Riemann sum. I promise. Okay, all I needed here was my position at any time is going to be my initial position. So 5 plus the integral from 0 to t of v of, I used big T and dt because I didn't want to use the t variable again. Okay, so that would be for 2 points. When is the particle farthest to the right? Farthest to the right means my position is greatest or my displacement is greatest. I want to make sure we get this one right. Let's look at the graph. Where could you be farthest to the right? Based on the graph, where would you look and why? Polymon, where would you look and why?
We'll look at points where A, B, and 0.
Okay, well, yeah, I've labeled those. But why did I label those? Why those points and not these points? Carmen, why the points that I labeled but not the other ones?
Because the graph V of t is changing from positive to negative.
Right, at A, your velocity changes from positive to negative. So what's happening to your position? If velocity changes from positive to negative, what am I doing? I'm changing from going like, well, for your perspective, like from going to the right, stop, go to the left. So my position could be greatest over here. Not over here because the change is wrong. I'm changing from going left to now going right. So over here, and why at C? There's one really good reason why we would consider C. It's an endpoint. That's all. So what I did is I just said, okay, I've got my candidates are t equals A, t equals B, t equals C. Find your displacement at A, 0.894. Displacement at B, 0.788. Displacement at C, 0.752. I'm farthest to the right at time A. Curious, did anybody get this one right? One person out of 11? 2 people out of 11? I would put a star next to this one. This one is huge. Absolute max, absolute min. It is going to come up again and again and again. It's going to come up on the homework assignment that you're going to do not tonight but tomorrow night. It's going to come up on the unit test. Absolute max questions always show up again and again and again. Or absolute min. All right. So while that's happening, Carmen, if you wouldn't mind picking up, I'd appreciate it. Tomorrow I'm going to stay after school from 1:15 to 2:30, and then at 2:30 I have got to boogie on out of here. We're meeting with the social worker who's going to help us with the adoption process. So at 2:30 I will shove you out of the way if I need to. All right, tonight's homework assignment is assignment number 81. I don't need you to do all of it. I need you to do problems 1, 2, 4, 5, and 6, and then all the multiple choice questions. Here you go, Steven.
I did well this one.
Yeah, it's assignment 81. I know what I just gave you. Yeah, number 81. And what I just passed out is the second part of the problem set packet. Remember yesterday we had the conversation that I blew it when I made the copies? Yeah, my apologies. So what you're getting is the final part of the problem set packet, so you have access to that. But tonight's homework is just assignment 81.
There's no 6.
1, 2, there's no 6?
No.
1, 2, 4, 5. No! Okay, tonight's homework, 1, 2, 3, 4, 5. Woo! Let's just keep that between us. So that means you guys didn't get the last page of assignment 81.
Yay.
So 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5.
We're doing all of it?
Lewis,
Oh,
1, 2, 3, 4, 5. So technically you're doing all of what you got.
Just do the last page.
Do the last page. That's another way to say it. Everybody okay?
I'll write that on the-
All the friends are good. All right. So I want to take you guys on a little trip. We're going to go on a trip through time. At one time, you guys may know this, at one time in my life I actually taught kindergarten. I loved teaching kindergarten. They were so good with the power rule. Man, those kids mastered the power rule. They could bring the stuff down. Quotient rule, not so good, but no. Seriously, I taught kindergarten. I loved teaching kindergarten. And then at some point I was like, no more. I've also taught middle school. Cannot say I loved teaching middle school. The sticky humans and me, not a good combination. But here's what I know. When I taught elementary school, we talked about finding average. When I taught middle school, we talked about finding average. When I did SAT prep, we talked about finding average. This idea of finding the average shows up again and again and again in certain ways before calculus and in a completely different way starting today in AP calculus. So what I want you guys to do is take 3 minutes, just 3 little minutes, completely on your own, no help from anybody, and your goal is to complete the elementary school problem and the middle school problem. Do not embarrass yourselves and get them wrong. Read it carefully. We'll talk in 3 minutes. Use your calculator if you need to. Now I gotta tell you, I am interested partially in your number. I'm always interested in your units, and I'm interested in your explanation. I want the full package. A number alone isn't going to cut it. Lucy, what's that? Does he have diabetes? No. Focus.
You sure about that?
I'm sure.
Eating 122.
Focus! If I'm going to yell at you, I got to get it out before our visitors get here. David's just going to start twitching. He yells all the time. Help me. Just watch the video. The elementary school problem and the middle school problem, please. Okay, the right number answer is not what Stephen has on his paper.
Oh, it's awkward.
For which one?
Wait, Steve, what do you have?
Steve, what is that?
The right number answer is 64.
Oh,
What did you do?
Don't focus. Move on. Move on.
oh wait, what?
He.
Oh,
See, these are not the kinds of things you can Google.
It didn't make sense.
Okay. care about your explanation? I don't see anybody writing a sentence.
You need an explanation.
You need an explanation. It says, write your final answer in a complete sentence. Oh, time's up. All right, so if all went well on the elementary school problem, right, what I saw most people do, they said, okay, 23 plus, what is that, 79, plus 32, plus 122, and they divide it by 4, and they get 64, and everybody's okay with 64.
See,
Except, you know,
Steven.
Steven. Okay, M&M's per day has to be the units. An average, this is a rate, we're looking at an average rate. Now what I didn't see anybody do in their explanation is, when is this average good for?
Oh, Monday through Thursday.
For Monday through Thursday. So what I'd want to see is something like, for the first 4 days. Give me the rest of the sentence. For the first 4 days, what happens?
Jeff.
Jeff ate or Jeff eats. I would say Jeff eats M&Ms at an average of what, 64 M&Ms per day. You have to tell me in your explanation, when is this average true? What is the average? And what is it that we're finding the average of? So the average is true for these first 4 days. What are we finding the average of? Jeff eating M&Ms. He eats them at an average rate of 64 M&Ms per day. I have no doubt that everybody in the room is going to be fine getting to the 64. Easy peasy. The units, maybe not too bad, but it's the explanation I care greatly about. So with that said, please fix your answer to the middle school question. Fix that answer to the middle school question. Interesting. I'm not seeing the right numerical average on the middle school question from anybody.
Oh, that's
Multiplied by the
Oh no. Wait. Seriously, so actually you're included.
Alright, so real quick thing. Popular wrong answer,
I was right, it was
11.667.
35.
Popular wrong answer is 35 over 3,
Oh, God, I was
11.667.
like, my initial thought was
Somebody,
35.
why is this wrong? What is this person forgetting about? Aaron, what are they forgetting
It's
about?
the per hours. So you have to add it. You have to multiply each number by the hours that they said.
Right. This, we're not just saying it's 15 M&Ms per hour once, or 12 M&Ms per hour once. So it's 15 M&Ms per hour. How often? Okay, so 4 times, and then it's 12 M&Ms per hour for 5 hours, and then what?
8 M&Ms for the last 6 hours.
8 M&Ms for the last 6 hours, and we're going to divide by
16.
16 or 15?
16.
16. Okay, if you do that one right, 10.5. Okay, 10.5 is the number. I care about the sentence and I care about the units. So 10.5 M&Ms per hour. Take a minute, get me that perfect sentence.
That's an odd.
That perfect answer, you're going to tell me when is this average true? What's the numerical value? What are we finding the average of?
the 16 hours here.
So Palomone, what do you got?
What?
Same for the first.
E8. 10.5.
Okay, but tell me when it's true.
You started the sentence right.
You started the sentence already. What start when's it true?
For the first 16 hours.
Thank you! Oh my god, you don't even listen to yourself. That explains so much. For the first 16 hours. Okay, for the first 16 hours. Call them up, finish it up.
Of the day.
For the first 16 hours. How about Jeff?
Jeff eats 10.5 M&Ms per hour.
So I want to say eats M&Ms at an average rate of 10.5 M&Ms. Okay, all the side conversations are driving me nuts right now, and to be honest. Is everybody okay with coming up with the numerical value?
Yes.
Okay, I've got to push you past the number answer. You guys are going to get here and stop like, great, 1 point out of 3. I need the units and I need a full sentence. That full sentence, you got to tell me when this is true, what is it that we're finding the average of, and what's the actual numerical value. So with that said, find somebody that you are not currently working with, somebody you're not currently sitting with, and go for the calculus problem. You're going to get no support from me on the calculus problem. Show me what you can do.
Andrew, you get the.
I'm working with
Andrew, you get the camera.
Yeah, I don't know.
Don't worry about it, Andrew. Just work with Giselle and Carmen.
Oh, sorry.
Bye.
And you guys are partners?
Yes.
Okay.
Over the course of a 12-hour period of time. Using the information using the average rate at which Jeff completes and gives 12 hours period of time.
Which one?
Yep,
So you find the area.
So
4 hours in a year.
the average. That's how many.
What?
0 to 3 hours.
So we know.
Both the elementary school problem and on the middle school problem, the way that you found the average, we had to look at the total number of M&Ms and then divided by the number of days and the number of hours. Same idea here.
Wait a minute.
Mm-hmm. Take 1 more minute. Yep.
Is it possible to do it? Because you're just finding the total number. The total number, in order to find the total number, you have to partition the units. Like that. Yeah. How is that?
That's telling you how fast he's
Okay.
eating the
That
M&Ms.
makes sense. You just
If,
find
how are you going to
find
figure
area.
out how many M&Ms? It's an area problem.
Because you have to find, that's the rate, the graph is the rate, you can find the total. You find the total rate, yeah. So you just find the total rate and divide it by 12.
Well, you're, yeah.
Average rate. So in order to find the average rate, you have to add total rates. Divided by 12. Yeah, but to find the average rate, you can't think of it as a rate. Now you find the average, how do you find the average? You add them all up and divide them by.
Okay, I think all the groups have kind of unraveled the mystery here. The way that you found, hold on, The way that you guys found average in elementary and middle school was you take like the total number of things and divide it by the number of things, right? With the M&Ms, it was the total number of M&Ms divided by the number of hours or the number. So here, how am I going to get the total number of M&Ms? It's just a little bit different. The way I'm going to get the total number of M&Ms, if my function is rate, rate means how fast, right? How fast Jeff's eating M&Ms. How do I find how many he eats? You're going to find the area. You're going to do an integral because we're integrating, what's the name of the function here? Is this j of t?
Yes.
Okay, so if j of t is how fast Jeff eats M&Ms, then this definite integral has to be the total number of M&Ms. Everybody's okay with that? So we're going to do an integral from 0 to 12. If all you do is the integral from 0 to 12, what you're going to get me is like the total number of M&Ms that he eats. And so I saw a lot of folks breaking this up and saying, okay, I've got a rectangle, I've got a trapezoid, we've got another trapezoid. Does anybody come up with the total area?
89.
89?
Yeah.
Okay, and I'm going to divide that by 12. Now 89 divided by 12 is like
416.
416.
M&M's
Hundreds of M&Ms.
And what?
per hour.
M&Ms per hour? Hundreds of M&Ms per hour?
Hundreds of M&M's per hour.
Hundreds of M&Ms per hour. You have to get the units right. So hundreds of M&Ms per hour. This last one is fiction. No, he was not eating 7.416 hundreds of M&Ms per hour. But I need the full sentence, that full explanation. When is this average true? From t equals 0 to t equals 12. What am I finding the average of? This is like the average rate that Jeff eats M&Ms is 7.416 hundred M&Ms per hour. I need the full set. You're going to do a lot of writing with this. So first I want to get like your time interval. So from a place to a place, you're going to tell me the average something, and then you're going to give me the number with the units. Time interval, the average, what's the function that you care about, what's the number, what are the units. Everybody okay? This is how we're going to find average. All right, so let's push a little more. You guys are going to need your calculators for this. We're going to do maybe 3 problems. I think you guys are going to like blow through these now that you've got the big idea. All right. All right, so we've talked about Jeff, we've talked about rate functions, we've talked about M&Ms, it's not all going to be about M&Ms. Some textbooks call this guy the average value theorem. I'm not going to necessarily worry about calling it the average value theorem. It's just the average value process. What happens is if you have some function f of x, and I want to find the average value of the function on some interval a to b. What? No, we have an IVT, the intermediate value theorem. We have an EVT, the extreme value theorem, and we have a MVT, the mean value theorem, and we have an SDT, the second derivative test.
Oh.
Not to be confused with STD. Very confusing.
I was like,
Okay, I try not to abbreviate that one because sometimes.
I was like, I'm done.
Everybody get average value theorem? So here's what the average value theorem says. If I want the average of some function, f of x, on some interval, ab, well, what did we do with the M&Ms?
Oh, definitely.
You found the definite integral because the definite integral tells you total. So what we're going to do is we're going to find the definite integral. Now we're going to be careful here. The reason that you find the definite integral is that this is it's a total, it's an accumulation. in that M&M problem, it wasn't just find the area and be done with it. It was find the area and then you had to do something else with the area.
Divide
You had to divide. What do we divide by?
by interval.
By the interval.
By the length of the interval, by how much time it took him to eat all the M&Ms. So we're going to take total and we're going to divide by length. In this case, the length of the interval
B minus A.
is going to be b minus a. So you find the total for the function on the interval, and you divide by the length of the interval, and that's going to give you the average. And hopefully that makes sense. Just think about that M&M example. Now, some textbooks like to write it this way. They're going to say 1 over b minus a, the integral from a to b of f of x dx. Same thing. Right, Lewis? Why is it the same thing?
You just multiply it, they'll be on the top of it.
Right? 1 over b minus a times all this just puts the b minus a in the denominator. Write it down this way, write it down that way. I'm gonna show it to you both ways. I just want you to be really comfortable with this. Everybody okay? I bet now that you've got this one, the rest of the problems that we're gonna do over the course of the next 10 minutes or so are gonna go really well. All right, for the function shown at the right, determine the average value for the function on the interval -3 to 6. What you need to know is that the portion of the graph from 0 to 4 is a semicircle of radius 2. So go get me that average value. Maybe have a quick strategy conversation with somebody near you, and then get to it. Or not have the strategy conversation with somebody near you.
What's the area?
Okay, you're going to find the area, because you want to find the average value. You're going to find the area, you're going to add them all up, and then, and then we're just going to divide. We're just going to divide. Cool. Total area.
Wait, what's the graph from x equals 0 to x equals 4?
Just 2 pi. You gotta multiply it by 1/2. Divide by 2.
If I'm thinking about how I'm going to score a problem like this, showing this initial setup is going to get you the first point. You're finding that total from -3 to 6, you're dividing by the length of the interval. Or if you want to write this as 1 over 9, the integral from -3 to 6, f of x dx, would be great. Myra, what's your plan? How are we going to find the definite integral from -3 to 6?
Split the whole thing into triangle, semicircle, and triangle.
Good. We've got x equals -3. We've got x equals 6. So I've got region number 1, region number 2, region number 3. You guys know the only thing really that you got to worry about here, semicircle has to have a negative area. Okay. Anybody get the area yet?
It should be, well,
2 pi plus
area
9
there,
plus
but I got 15.
Area over here, area over here. Subtract this area.
2 pi.
Is it 15 minus 2 pi?
Yeah.
So 15 minus 2 pi is the area. Divide by 9. Is everybody okay with 15 minus 2 pi over 9?
Yes.
Okay, good. We got this totally under control. All right, let's see what you can do with the calculator. Try the next one. I'm a pusher. Steven, if you want to use your integration skills on this one, feel free. That function -3x squared plus 6x plus 1. Find the average value for the portion of the function which is contained in the first quadrant. Oh yeah. Alright, I'm totally cheating off of ILA here. So ILA graphed it and the graph looks something like that. Yeah. Something like that. Okay, I want the average value for the part of the function which is in the first quadrant. First quadrant starts over here, ends at whatever that root is, so like that's what I want. So the big question is, where do you start? Where do you end?
Sort of 0.
We're going to start at x equals 0. I completely agree. Where do we end?
2.1547.
Okay, 2.1547. Anybody else getting 2.1547? Now here's the thing. I want your answer to be as exact as you can get it to be. I know they say three decimal places. I want this to be exact. You guys haven't done this in a while. Store that value. So remember, you like take the little mouse and you're gonna like click on the 2.1547, and then it's store, variable, give it a name. Call it A, call it B, call it C, doesn't matter to me what you want to call it. Sorry, I didn't think to plug in the laptop. Okay, what's wrong? Okay, so you hit escape for a second. Hover over to the number. Okay, click on it, just once, so it's highlighted. There you go, and now var. Store var. Give it a name. You okay with store? So you okay with store? Okay. Friends over here, we're okay with store. It's just by storing, you're going to get a much more precise answer.
No. Yeah.
So you, yeah, show them how to store. Okay. So you take your little mouse and you hover over to the coordinate that you want. Click on it once. Okay. So once you get the root, hover over to the part that you want to store. Move your little mouse with the little pointer to the 2.154. Click once. So it highlights the 2.154. All right, so the average value is going to be found by doing the integral from 0 to 8. F of x dx divided by a minus 0 or just a. Another point for the setup. Probably a point for finding the root. And the thing I care about, what's that final number?
2.8.
2.8.
2.23.
2.8. 2.14.
2.82.
Oh,
Wait, 2.823 or 2.8214?
2.8214.
2.8214 with attitude, so it must be right.
2.8223.
It's 2.8223.
Yeah.
Okay, anybody else up front? I should have plugged in my calculator so we could do it. Eileen got 2.8214. Stephen, based on your inability to add numbers and divide earlier, I'm going to think that you're probably wrong. Okay, so we're going to go with 2.8214.
No, it's because I did it more accurate. I included the 0.0. I mean, I did 2.1547005.
Right, but if all the friends are storing, they're even more accurate than that.
Yeah, you're right.
You got me? So that's why you're off by a little bit. All right, so now that we've got the crutch out of the way, let's put the calculators away, shall we?
Yeah.
4.
For partner practice. Find somebody that you haven't worked with yet. Show me what you can do with this next one. Calculator inactive is what it should say.
Okay, active.
Calculator inactive is what it should say for you guys. If you need to use your calculator first, it's okay, but you guys should be able to do this without your calculator.
Yeah.
Oh, this is cold.
Could you solve
calculator in there?
Yeah.
If you need to use your calculator, that's fine. But then I'm going to ask you to do it again without your calculator, because you should be able to do this without your calculator. You need to be able to do this without your calculator.
Sine of 5 over 4 is sine of 45. It's root 2. Root 2 over 2.
Wait,
Mm-hmm.
it's just zero.
Mm-hmm.
What? Oh, it is 0.
Mm-hmm.
Cancel out.
This is why I want you to also be able to explain this without your calculator.
They can't.
Not an even
Not an
function.
even function.
0 over pi over 2.
Yeah.
Negative.
Because when we do this,
Assuming.
they can't figure out the intervals. The values of the intervals can't figure out.
Root 2.
So for the folks that have done this on their calculator, a lot of folks did negative pi over 4 to pi over 4, sine of x dx. Divide by pi over 4 minus negative pi over 4. I don't expect anybody yet to know how to find the antiderivative to evaluate. We don't know how to do all that. However, when you go to your calculator and you get 0 for an answer, I hope this is pushing you to think like there's something going on here.
Yep.
What's the something going on here? Why 0? What is it that you know? Why on earth would I ever expect you to do this without a calculator? 2 people out of 11. A little worried. Think about what you know. David, what do you know?
Sine of x is odd function.
Right? The graph of sine of x, whether you know to call it an odd function or not, think about the graph of the sine function. What I heard up front was you have like rotational symmetry, meaning that like the graph looks something like this. That's why we call it an odd function. What I want you to find is the area from negative pi over 4 to pi over 4. Because you have an odd function, because you have the rotational symmetry, what's the total area between negative pi over 4 and pi over 4? 0. These guys cancel, and so if the numerator is 0, then what you're dividing by is going to keep this equal to 0. Everybody good? Alright, I got 2 more problems that I want to push you guys on. So find a new partner. We're going to go to problem number 5. And problem number 5 is calculator active.
Number 5?
Problem number 5. Myra doesn't move. She makes people come
Oh,
here.
yeah. Oh. Yes.
Okay.
You have to find the derivative because it's acceleration in the case of velocity.
And on this one, I want the sentence. Andrew, here you go. Lewis, John. I told you your smarticle particles did not completely leave you. All right. Assuming it takes her 3 seconds to reach the square, I'll determine the average acceleration. Okay, so from 0 to 3, and I'm dividing by 3 minus 0. That must be it. Most popular wrong answer if this class was filled with people that aren't reading carefully. Why is it not this? Why can't it be that setup. Only David sees it. Almost nobody actually did this in class. David, why is this wrong?
Because asking for acceleration.
I want average acceleration, right? If what you want is the average acceleration, the only thing you can get out of this setup here is your average velocity. So if I want to get to average acceleration, you know what we're going to have to do?
Derivative.
You're going to have to take a derivative and then use that in your integration. So if your velocity function is e of t sine of t, to get to acceleration, well, I need a derivative. If I'm going to take the derivative of e to the t sine t, and I'm really thinking and all the smarticles are rowing in the same direction, Polymon, how are we going to find the derivative? How are you going to find the derivative the right way here? Chain rule?
Yeah.
Yeah, but it's still gonna be one.
It's gonna be the same. The only thing you're changing is color.
Well,
To color.
e to the t sine t, the way that I would hope that you would read this is e to the t times sine of t.
So we do the product.
So which rule?
Product.
Product rule. This has to be product rule. Like, I was not kind, I did not put the multiplication dot in there. You need to know that there's the multiplication dot in there. Okay, so the derivative, product rule says derivative of the first, leave the second alone, plus the first, times the derivative of the second. That's your acceleration. And so to find the average acceleration, integral from 0 to 3, e to the t sine t, e to the t cosine of t, dt, over 3 minus 0. Anybody get a numerical answer on this one yet?
Wait.
So you found the derivative to get to the acceleration. Average acceleration, average anything, you're going to integrate the function over the interval that you care about, and you're going to divide by the length of the interval that you care about. So all I need to know is what's the number answer that we're going to get out of the calculator.
I might try.
Yours is charging, so you've resorted to petty theft. Okay, Celeste, what did you say the number was?
0.9448.
0.9448. Can anybody confirm 0.9448? LA's got 0.9448. Other folks seem to have 0.9448. I agree, we're going to get 0.9448 in the units. The units for average acceleration.
Meters per second.
Think about what is it that you're finding the average of? Acceleration. How do I measure acceleration? It's going to be a meters per something squared. Meters per second, meters per second squared. Either way is fine. The explanation, and like in the homework that you're going to do tonight, it's not just the number. I need the sentence. And the sentence starts with, when is this true? From t equals 0 to t equals 3, what did I find the average of? This is the average acceleration is 0.9448 meters per second squared. Okay. Now for all my AP Physics folks, you have another way to find average acceleration.
I'm sure Mr. T does.
There's another way to find average acceleration
Yeah.
that all the AP Physics folks know,
What's that read?
are responsible for knowing.
Carbon?
Oh, so awkward. The other way to find average acceleration is, so average acceleration, you look at change in velocity over change in time. Your change in velocity just is, what's the velocity at time 3 minus the velocity at time 0 divided by 3 minus 0. For my Googling friends, if this is acceleration, and you take the antiderivative, Stephen?
Wait.
The antiderivative of acceleration would be velocity, and then the fundamental theorem of calculus says evaluate velocity at 3. The evaluate velocity at 0, subtract them from one another, and divide. Don't worry about that. All right, last one. See what you guys can do. And you can just stay with whoever you're working with. I'm not saying that was going to happen. All right, I just want to make sure you guys at least get this in your notes. So you want to find the average value of this function on the interval -2 to a. Well, how do we find average value? You're going to integrate the function from -2 to a, and you're going to divide by the length of the interval. So a minus -2. Now the problem is this though, how do you find the definite integral from -2 to a of a piecewise function? Trust the instincts here.
You have to split it up.
You're going to split that piecewise function up. Where do you split it?
Add 0.
Right, so we're going to say it's the integral from -2 to 0 of the first piece of the function plus the integral from 0 to a of the second piece of the function. And you're going to divide by the length of the interval, which is a plus 2. And for the folks who are like, but wait, is that legal?
Yes.
Yes.
Right? If I'm saying find the area from -2 to a of any function, what you do is say, all right, I can go from -2 to a, or I can go from -2 to any place and stop, and find the area from that place over to a and finish it off. And so the natural stopping point here for a piecewise function is going to be at 0. Everybody good?
Yeah.
5 problems tonight are not going to take very long at all. I think they're all calculator active. I want number, unit, and sentence. See you later.
And then I collect it, and I will go to it.